Titanoboa's rivals, the massive snakes of prehistoric times. Welcome to our in-depth exploration of the colossal serpents that once dominated prehistoric Earth. In Titanoboa's rivals, the massive snakes of prehistoric times, we journey back millions of years to uncover the incredible stories of the giant snakes that rivaled the legendary Titanoboa. These prehistoric giants, from the dense jungles of South America to the ancient seas of Europe and the vast landscapes of Africa and Australia, ruled their environments with unparalleled might. Join us as we delve into the fascinating details of their lives, examining their massive sizes, unique adaptations, and formidable hunting strategies. Learn about their interactions with other ancient creatures and the ecosystems they dominated. Through the latest paleontological discoveries and scientific insights, we will reveal the astonishing diversity and complexity of these prehistoric predators. Prepare to be amazed by the epic tales of Titanoboa's formidable rivals, the massive snakes of prehistoric times. Chapter 1. Introduction to Prehistoric Giants. The world of prehistoric times was a place of wonder and terror, filled with landscapes teeming with life forms that seem almost alien to us today. Among these ancient inhabitants were the colossal serpents, massive snakes that dominated their ecosystems as apex predators. The most famous of these is Titanoboa kerajanensis, discovered in the Cerrejón coal mines of Colombia, which lived about 60 million years ago during the Paleocene epoch. However, Titanoboa was not the only giant snake that roamed the Earth. In this chapter, we introduce the main rivals of Titanoboa and set the stage for a detailed exploration of their lives, habitats, and interactions. Prehistoric ecosystems were vastly different from today's world. The climate was often warmer and more humid, and the flora and fauna were both more diverse and more robust. In the Paleocene epoch, which followed the extinction of the dinosaurs, reptiles such as Titanoboa thrived in the dense, swampy jungles of what is now South America. These ecosystems were rich in large prey, including ancient fish and early crocodilians, providing ample food for giant snakes. This chapter also touches on the significance of these ecosystems in the broader context of Earth's history. The diversification and dominance of reptiles during this time illustrate the resilience and adaptability of life on Earth following major extinction events. By setting the scene with an overview of these prehistoric environments, we can better appreciate the role that giant snakes like Titanoboa played in their ecosystems and how they influenced the evolutionary paths of other species. Chapter 2. Titanoboa, the King of Serpents. Titanoboa kerajanensis, the undisputed king of snakes, dominated the tropical rainforests of South America around 60 million years ago. This giant serpent, measuring up to 42 feet in length and weighing over a ton, was a true apex predator. Titanoboa's reign was uncovered in 2009 when scientists discovered its fossilized remains in the Cerrejón coal mines of Colombia. In this chapter, we delve into the life and times of Titanoboa, exploring its physical characteristics, hunting strategies, and the ecosystem it dominated. The discovery of Titanoboa was a groundbreaking achievement in paleontology. Fossilized vertebrae and ribs provided crucial insights into its immense size and structure. Titanoboa's physical attributes, such as its vertebrae and ribs, suggest a snake that was not only massive, but also incredibly powerful. The vertebrae are particularly revealing, showing a robust structure that supported its enormous body. This chapter also discusses the probable coloration and skin texture of Titanoboa, drawing comparisons with modern snakes to infer these characteristics. We will reconstruct its likely appearance and behavior, shedding light on how it navigated its lush, swampy environment. Titanoboa's diet likely included large fish and possibly crocodiles, as evidenced by the presence of fossilized prey items in the Cerrejón Formation. The climatic conditions of the Paleocene epoch, which were warmer and more humid than today, provided an ideal environment for such a large snake. The chapter also addresses the significance of Titanoboa's discovery in understanding snake evolution and the factors that allowed such a giant predator to exist. By examining the anatomy and ecology of Titanoboa, we gain a deeper appreciation for the complexity and scale of prehistoric life. The chapter concludes with a discussion on how Titanoboa's dominance impacted the ecosystems it inhabited and its interactions with other large predators of the time. Chapter 3. Gigantophis, Africa's ancient predator. Before Titanoboa's discovery, Gigantophis gustini was known as the largest snake. This formidable predator inhabited the swamps and floodplains of Eocene Africa around 40 million years ago. Gigantophis reached lengths of up to 33 feet, making it a true giant of its time. In this chapter, we explore the life and times of Gigantophis, its interactions with contemporary fauna, and how it compares to Titanoboa. Fossil remains of Gigantophis, primarily vertebrae, have been found in what is now Egypt and Algeria. These discoveries have provided valuable insights into its size and structure. The Eocene epoch was a time of significant ecological change, with a warm climate and abundant wetlands supporting a diverse array of life. Gigantophis thrived in these lush environments, preying on a variety of animals, including early mammals and large birds. This chapter examines the habitat of Gigantophis, focusing on the unique characteristics of the Eocene wetlands that supported such a large snake. Comparisons between Gigantophis and Titanoboa highlight their similarities and differences in size, behavior, and ecological roles. While both snakes were giants in their own right, their environments and prey differed significantly. Gigantophis, for instance, might have had a more varied diet, including not only aquatic prey but also terrestrial animals. We will explore how Gigantophis might have hunted and what its presence tells us about the prehistoric ecosystems of Africa. This chapter aims to paint a vivid picture of a time when giant snakes like Gigantophis were the apex predators of their realms. The chapter concludes with a discussion on the evolutionary significance of Gigantophis and its role in the broader context of reptile evolution. Chapter 4. Madsoia, the South American titan. Madsoia bai was another giant snake that lived in South America, but during the late Cretaceous period, around 85 million years ago. Known for its robust build and impressive length, Madsoia was one of the top predators of its time. This chapter examines the paleontological findings related to Madsoia, its physical characteristics, and its role in the Cretaceous ecosystem. The discovery of Madsoia fossils in Argentina has provided significant insights into this ancient predator. We will discuss its unique vertebral structure, which suggests a powerful constrictor capable of subduing large prey. The vertebrae of Madsoia are distinctive, showing adaptations that likely supported its massive body and constricting capabilities. The late Cretaceous period was characterized by a warm climate and the presence of diverse ecosystems, ranging from lush forests to arid regions. Madsoia's environment, characterized by lush forests and diverse fauna, will be explored to understand its place in the food chain. The chapter will examine the interactions between Madsoia and its contemporaries, including various dinosaur species that coexisted in its habitat. We will also discuss the potential interactions between Madsoia and the dinosaurs that shared its habitat, shedding light on the complex dynamics of prehistoric ecosystems. By examining the life of Madsoia, we can better understand the evolutionary pressures that shaped these giant serpents. The chapter concludes with a discussion on how Madsoia adapted to its environment and the evolutionary legacy it left behind. Chapter 5. Palaeophis, the marine serpents. Not all giant snakes were confined to land. The Palaeophis genus included some of the largest marine snakes that ever lived, thriving in ancient seas during the Eocene epoch. These serpents grew up to 30 feet long and were well adapted to their aquatic environments. This chapter explores the marine habitats of Palaeophis, their adaptations for an aquatic lifestyle, and their hunting strategies. Fossils of Palaeophis have been discovered in various locations, including Europe and North America, indicating a wide distribution. We will examine the streamlined bodies and specialized vertebrae that allowed Palaeophis to navigate the waters efficiently. The vertebral structure of Palaeophis shows adaptations for a powerful swimming motion, similar to modern sea snakes. The chapter will also discuss the different species within the Palaeophis genus, comparing their sizes and ecological niches. Some species were adapted to shallow coastal waters, while others thrived in deeper marine environments. The diversity of Palaeophis species highlights the adaptability of these marine serpents to different ecological conditions. Additionally, we will explore the potential prey items of Palaeophis, such as fish and other marine reptiles, and the evolutionary pressures that led to the development of such large marine snakes. By studying Palaeophis, we gain a deeper understanding of the diversity and adaptability of prehistoric marine life. The chapter concludes with a discussion on the role of marine snakes in the ancient oceans and their evolutionary significance. Chapter 6. The enigmatic Yurlungur. In the ancient forests of Australia, the Yurlungur genus included some of the continent's largest snakes. Yurlungur camfieldensis, known from the Miocene epoch, provides a fascinating glimpse into Australia's prehistoric past. This chapter delves into the discovery and significance of Yurlungur, its ecological niche, and its place within the broader context of prehistoric megafauna. Fossils of Yurlungur, primarily vertebrae and ribs, have been found in the Northern Territory, offering clues about its size and lifestyle. We will explore the physical characteristics of Yurlungur, its possible diet, and its interactions with other large reptiles and mammals. Comparisons with other giant snakes will help illustrate its unique adaptations and survival strategies. The chapter will also discuss the climatic and environmental conditions of Miocene Australia, highlighting how these factors influenced the evolution and distribution of large reptiles. During the Miocene, Australia was home to diverse habitats ranging from dense rainforests to arid regions, providing a variety of ecological niches for reptiles like Yurlungur. By examining Yurlungur, we can appreciate the diversity and adaptability of prehistoric snakes. The chapter will explore how Yurlungur adapted to its environment, including its possible prey and hunting strategies. The chapter concludes with a discussion on the evolutionary significance of Yurlungur and its contributions to our understanding of snake evolution. Chapter 7. Laophis, Europe's forgotten giant. Laophis crotalloides, a lesser-known giant snake from the Miocene of Greece, represents Europe's contribution to the pantheon of prehistoric serpents. This chapter uncovers the scant fossil record of Laophis, piecing together what is known about its size, habitat, and lifestyle. Laophis was a large constrictor, possibly reaching lengths of up to 30 feet. Its fossils, discovered in Thessaloniki, have provided limited but valuable information about its morphology and ecology. We will explore the environment of Miocene Greece, a region characterized by warm climates and diverse ecosystems. The chapter will discuss the potential prey items of Laophis, including small mammals and reptiles, and its role as a top predator. During the Miocene, Europe experienced significant climatic changes, with periods of warming that created lush environments supporting diverse fauna. Laophis thrived in these conditions, adapting to the available prey and ecological niches. We will also address the challenges paleontologists face in studying such elusive creatures and the potential for future discoveries that could shed more light on Laophis and its relatives. The chapter will conclude with a discussion on the evolutionary significance of Laophis and its role in the broader context of snake evolution in Europe. Chapter 8. Gigantism in snakes: Causes and Consequences. What factors contributed to the gigantism seen in these prehistoric snakes? This chapter investigates the environmental, ecological, and evolutionary drivers behind the massive sizes of these serpents. Topics include climate conditions, prey availability, and competition with other predators. Gigantism in snakes is a fascinating topic, influenced by a combination of factors. We will explore how warm climates during certain geological periods allowed for larger body sizes, as snakes are ectothermic and rely on external temperatures for thermoregulation. The availability of large prey items, which would have supported the growth of giant snakes, will also be discussed. Additionally, the chapter will examine the evolutionary pressures that favoured larger sizes, such as reduced predation risk and increased hunting efficiency. The consequences of gigantism, including metabolic demands and reproductive strategies, will be analysed to provide a comprehensive understanding of this phenomenon. We will also delve into the potential trade-offs of gigantism. For example, while larger body sizes might offer advantages in terms of prey capture and deterrence of predators, they could also come with increased energy requirements and slower movements. Understanding these trade-offs helps us appreciate the balance these ancient giants maintained in their ecosystems. The chapter will also explore the role of gigantism in the broader context of snake evolution. By studying the factors that contributed to the massive sizes of prehistoric snakes, we can gain insights into the evolutionary pathways that led to the diversity of snake species we see today. Chapter 9. The Fossil Record: Unearthing the Past. The discovery and study of giant snake fossils provide a window into prehistoric ecosystems. This chapter details the methods used by paleontologists to unearth and analyze these ancient remains. We explore the sites of major discoveries, the technology used in fossil excavation, and the process of reconstructing the appearance and behavior of these long-extinct creatures. The chapter will begin with an overview of paleontological techniques, from initial fieldwork to laboratory analysis. Key discovery sites, such as the Cerrejón coal mines in Colombia and the Fayum Depression in Egypt, will be highlighted to illustrate the diversity of environments where giant snake fossils have been found. Advances in technology, such as CT scanning and 3D modelling, have revolutionized our understanding of fossilized remains. These tools allow scientists to reconstruct the anatomy and behavior of ancient snakes with unprecedented accuracy. Case studies of major discoveries, including Titanoboa and Gigantophis, will provide insights into the challenges and triumphs of paleontological research. We will also explore the role of fossils in understanding the broader context of prehistoric life. Fossils provide a snapshot of ancient ecosystems, allowing us to reconstruct the environments and interactions of long-extinct species. By studying these remains, we can gain a deeper understanding of the complexity and diversity of life on Earth during different geological periods. The chapter will conclude with a discussion on the importance of fossil preservation and the ongoing efforts to protect and study these invaluable resources. By safeguarding our fossil heritage, we can continue to uncover the secrets of the past and enhance our understanding of the natural world. Chapter 10. Legacy of the Giants: Modern Implications and Future Research. The study of prehistoric giant snakes not only enriches our understanding of the past, but also informs modern science. This chapter explores the legacy of these ancient serpents, from their influence on modern snake biology to their place in popular culture. We also look ahead to future research opportunities, considering how new technologies and methodologies might uncover even more about these fascinating creatures. The chapter will begin by discussing how the study of giant snakes has advanced our knowledge of snake evolution and biology. For example, the analysis of Titanoboa's physiology has provided insights into the limits of snake size and the adaptations required for gigantism. We will also explore the cultural impact of these prehistoric giants, from their depiction in literature and film to their influence on popular perceptions of snakes. The chapter will highlight ongoing research efforts and the potential for future discoveries. Emerging technologies, such as advanced imaging techniques and genetic analysis, hold promise for uncovering new information about these ancient giants. By continuing to study the fossil record and applying modern scientific methods, we can deepen our understanding of the complex and fascinating world of prehistoric snakes. We will also explore the broader implications of studying prehistoric life, including how these findings can inform our understanding of modern ecosystems and the impacts of climate change. By learning from the past, we can better prepare for the challenges of the future. The chapter will conclude with a call to action, encouraging continued support for paleontological research and the protection of our fossil heritage. By preserving these invaluable resources, we can ensure that future generations have the opportunity to explore and understand the rich tapestry of life on Earth. Thank you for joining us on this journey through time to explore the massive snakes of prehistoric times. From the towering Titanoboa to the enigmatic Yurlungur, these ancient serpents were truly remarkable creatures that played crucial roles in their ecosystems. Their fossils provide us with invaluable insights into the past, helping us understand the diversity and adaptability of life on Earth. If you enjoyed this video, please like, share, and subscribe for more fascinating content. For more information and resources,